CLI and a cross-platform IDE for C and C++. Download now.
Hey, welcome everyone. This is Rust Cargo Cult. This is some of the places where I've done some damage in the past or currently. I see lots of people here, so I'm just curious. How many of you are sort of Rust curious? As in, you heard about it, you're sort of interested, but you didn't have time to spend more on it. Okay. How about you saw some technical talks, you read some articles, read some books maybe, anything more investigation as in beyond just being curious, okay? How about maybe you try to build some sample toy projects or some hobby things or something like that? Okay, fewer hands, but still. How about by professionals, I just mean somebody's paying you to write Rust. Okay, just a couple of hands. I sort of expected that. Okay, so first of all, this is not a sort of Rust 101. I'm not even gonna sort of go deep in language level features and exploration in that sense, so definitely not. Also, I'm not here sort of to convert anyone. It's like, I'm not gonna tell you to rewrite your stuff in Rust. I'm not gonna sell you on its virtues, start any language wars. I'm gonna compare some things, but mostly from the engineering point of view, not from sort of language features or library features point of view. So this whole thing is gonna be just 3 things I like about Rust and 3 things I wish would be better. So what's so great about Rust anyway? Safety by default, spatial safety, temporal safety, thread safety, and concurrency, async safety. That's all the stuff that you saw from Greg earlier, just forget about it. It's like, just if you don't go out of your way to escape the type system, then you're just safe by default. Extreme range of operation, from the tiniest embedded things and firmware, and I'm gonna show you some examples of that, up to user applications, web applications, whatever you want. So it's very versatile in what you can do with it. That doesn't mean that other programming languages cannot do that, but it's usually a pain. So it ends up being a choose the right tool for the job kind of thing, right? Where you use maybe different frameworks or different languages at different levels of your stack or of your sort of application. Whereas Rust is more versatile, and when people sort of go this route, they tend to use it across their whole stack. And of course, community and ecosystem. That's a sort of one of the, maybe I should have put it first, but people expect to put safety first, right? So, but community and ecosystems may be one of the best strengths of Rust. And if it's really so great, why isn't sort of more hands like raised there when I asked at the beginning? So, in my opinion, 3 things sort of stand out. Enterprise-grade tooling, and I'm gonna explain what I mean by that. Ergonomic interop with existing stuff, you kind of have to meet people where they are. Rarely get the chance to just be completely greenfield and rewrite everything in a bubble from scratch and not interact with anything. So you need sort of ergonomic interop and efficient interop, and with less headaches. And maturity of the ecosystem. Like it or not, many of the industries still depend on all sorts of certifications, requirements on various ISO standards for various niches. And there's a plethora of companies who make a very good living out of doing these audits and assessments and things for other companies. So it's evolving quickly. So there's, because of the need, sort of solutions keep popping up, but it's not at the same level of maturity as established things like C and C++. So safety by default. So with C++, we all know we always have to sort of trade things, and it's difficult. We can do it. Definitely we can write safe C++, but we need lots of good tools. like you saw earlier, like lots of good tools and sort of good practice to get it done. And all sorts of recent snake oils like safety profiles and other things. Sure, they help. They sort of teach you to put the knives in the right drawers and not run with scissors and everything. But it's still sort of very much an active effort. And everyone sort of panics these days. It's sort of it's even no longer news. Sort of all these executive orders and mandates and requirements around safety from all sorts of government agencies, and for good reason. Like if we look, roughly 70% of memory safety issues are related to 70% of exploits are related to memory safety issues, right? And even sort of going one level deeper in sort of underlying causes, we should see the usual suspects like heap corruption, stack corruption, unsafe type usage, and so on. So it's sort of, I would say it's not surprising. And if I'm sort of being sort of pedantic to compare these things, there are sort of guidance and workarounds and things you can do for C++ and for even for C, but it's sort of a pain and it takes a lot of bandwidth and mental effort. So, and by the way, this is not a sort of a head fight here. I strongly believe these things need to play nice together for a long time, right? C++ code is being written every day, more and more so, and then we have a gazillion lines of C++ around. So anything that Rust will do in the industry will have to be playing nice and sort of this ecosystem thriving together. And that's literally what we're doing at Microsoft as well. We're making changes to our SD operations, updating them for sort of emerging technologies and use cases and best practices. We're enhancing the capabilities of CodeQL and learnings and sort of what we enforce in code quality and pipelines. We continue to invest in hardening C and C++ code because we have a lot, and it's not going away soon. We do standardize on Rust and other memory-safe languages for new components or new functionalities in existing components. We do support the community, and we have to assist developers when they make this transition. And that means heavily investing in Rust developer tooling, both internally and upstream externally. So there's talking about C++ hardening technologies. There's like an alphabet soup of stuff that has been developed over years, all sorts of mitigations over time, and more coming. Like it's unbelievable. It's a sort of a never-ending pursuit. And that doesn't mean that sort of previous things are no longer good, but you just need more things. I have another presentation sort of where I go into details about this. You can probably Google it. Talking about the extreme range of operation, from the smallest embedded firmware and things to Windows kernel things in all sorts of mobile operating systems and desktop operating system and servers, to cloud microservices, to including web applications and even user visible stuff. So sort of very versatile, like I mentioned. And people pursue Rust for different reasons. Sometimes it's for the safety thing, obviously. Sometimes it's for cost saving, optimizing operations. For example, migrating a service to Rust from .NET, for example, and save on costs of running that service, or improve its throughput or scalability. So people approach it for different reasons. Safety is just one of them. And I'm gonna sort of give you some examples from my world. Yeah, Rust is already in Windows kernel. This is sort of old news by now. Yes, there are Windows components that have been rewritten to Rust. You can watch that presentation if you want to sort of go deep dive on some of these things. And all sorts of interesting projects. And sort of, I listed here just a few highlights that I can publicly talk about, but you can probably figure out that there's more underway. to be disclosed as they're ready for prime time. So we're talking about Windows core components, microservices, and all sorts of projects. Some of them are firmware, security processors, hypervisors, super lightweight VMMs, dedicated hardware encryption cards, crypto libraries, and all sorts of stuff. So I won't spend time sort of going through each of them, but if you're curious, I don't, in the interest of time, you can grab me later, sort of, if you're curious about any of those things, I can tell you more about them. And even share some resources if you're curious, read them. We generally tend to publish blog posts about sort of some of these experiments. Recent one was running the Hyperlight WASM runtime, where you can spin up a micro VM in microseconds. Sort of amazing way to run some sort of OS-less workloads. Again, very fast and very good for sandboxing. Sort of maybe the future of micro web services. And more oxidation efforts in progress, both from C++ towards Rust and from C# to Rust. So more things are cooking. And while we do that, we learn. We learn by just doing, by exploring, by flighting, doing experimentation, and going in production with them. And we see direct impact. We see improvements in security and reliability. We see reduction in operation costs for various services. We gain experience by just doing more of these experiments. With each of them, we sort of learn what it takes to take something like this in production. We evaluate the costs of what it takes for a team to learn on board on this stuff. What are the actual costs of porting when it's just like a simple one-to-one port? Or what are the costs to writing new stuff in Rust and sort of make them work with the existing ecosystem? And sort of we're always trying to figure out what are the pain points, what are the gaps in tooling, and what we can improve to make the situation better. Debugging, again, another thing that sort of usually comes up. And of course, performance, right? We care a lot about performance in many of these things, so we sort of pay very close attention to what happens with performance in these ports. And of course, we evaluate the costs of maintaining these hybrid code bases over time, because this sort of is something that's not immediately visible when you're doing these new things. You need to factor in sort of what it will cost over time to maintain these hybrid things. And speaking of hybrid things, mentioned earlier, ergonomic and efficient interop. This is a highly important topic for a lot of people in the community, not just for us. Right? As soon as you're sort of on board on this journey, you quickly figure out all sorts of issues and discover various needs that you didn't account for initially in making these components fit together and working together nice. So it's all sorts of things across the board, from performance overheads of these API boundaries, boilerplates, and generated code for APIs and the sort of interop surface, all sorts of gymnastics with annotations, and sometimes the need to lower types in sort of at your vocabulary surface in APIs because you don't have a good mapping from one language to another. The need to sort of go down to CFFI, which is sort of kind of crappy, but if you have like a small surface, then it's okay. Working with dynamic libraries and dealing with API. API, again, it's a sort of the elephant in the room here when dealing with these interop at module levels, and how much of these you can actually automate, right? Because some of these things are costly to do by hand. Of course, build systems and so on. So this is just maybe a teaser. If you care about, I saw a bunch of hands going up at the end of my mini poll at the beginning, sort of people actually playing with this stuff. So if you're curious, I'm just gonna plug, I have a talk about these issues tomorrow morning. And talking about the ecosystem and enterprise-grade tooling, Rust has an amazing and thriving ecosystem. Lots of crates out there, very good stuff, right? But also lots of not so great things, right? When statistically, when you have such a high volume of things and people keep experimenting. And when you have an ecosystem that makes it so easy to create new stuff and just put it out there, that's maybe a sort of a symptom of how easy it is to be part of this ecosystem and to ship a crate. Then you have sort of varying degrees of quality of stuff, right? And you end up in this sort of classic XKCD thing where your mega dependency thing ends up being dependent on some weird crate that you're not even aware of, sort of down in your tree of dependencies. And the big problem is when you're building something like that is not ending up in a situation where you're either in a precarious situation of depending on a thing that's no longer maintained or became vulnerable or exploited, or there's sort of no way for you to easily replace it. So that's why in Rust adoption in enterprises, and this is sort of, we're not singular in this thing, is you need to have a proper way of doing crate reviews and evaluations and sort of provide guidance for teams in how to choose the right things, both for internal crates and external crates, even more so for external ones. So what should you use? How should you evaluate them? Where this evaluation should be recorded? What should be the criteria? What should be if you have multiple options for doing the same thing? What's the recommended crate I should pick up, right? If I have 4 or 5 options for a thing. And for many things, you have plenty of options. So it's sort of an analysis paralysis kind of thing, right? And also sort of be very deliberate. There's increasing demand in software to have a good set of and tracking their environment, tracking both dependencies and what it takes to make them sort of the giblets of your software, right? So tracking the SBOM of all the things that you depend on transitively, and also sort of the environment you need to have to build the thing, sort of to build a trust and sort of a checklist of the state of your application. So this is sort of actively being worked on. External crate dependencies come with inherent risk, right? They're super good. Some of them are super quite high quality, and they provide excellent functionality. But it's inherent. Some of them come with risks of security issues, stability issues, support, maintenance issues. You might end up depending on something that's no longer well maintained or something like that. So you have to proactively ensure that the enterprise ecosystem that you're building sort of is built on stable and thriving parts of the open source, right? Make sure you treat vulnerabilities and track vulnerabilities. Make sure you yank the right versions out of your dependency chains. Make sure you sort of flag them in your pipelines and mitigate vulnerabilities appropriately. So that's sort of a big area of concern and investment in tooling to make this happen. It can't be done by hand. You can't just like check your dependencies regularly or something like that. You need lots of tooling to help with this. And you have to have evaluation criteria that sort of assesses these things on sort of various axes and sort of tries to provide recommendations and some sort of scoring that is objective and how you should have confidence in a particular library. By no means this is not a Rust-specific need, but just by the thriving nature of the ecosystem and just the amount of stuff out there, it just makes it all the way more important, right? And C++, when you usually need a library for something, you usually have 1 or 2 options and you kind of know which one to pick. Just because of sort of length of stay or sort of lack of options sometimes. Whereas in Rust, it's like paralysis in terms of choice. So you need sort of a way to automate this and have a system in place to make this happen. If you're curious, this is a very nice presentation about crate security. It's not necessarily Rust all the way. Yeah, sure, it is in the context of Rust crates, but I think you can learn a lot from this kind of stuff, just in general. So with that, is like it's when people tell you that you can just rewrite stuff in Rust or just easily jump on this bandwagon, it's deceivingly so. But it's not just like that. there's a lot of sort of cost that comes after that, and sort of you need to put more into it than just oh well, just hop on the next new thing and just hope that everything will just work. All right, like I said, find me afterwards. I finished perfectly on time. Find me afterwards if you're curious about any of this stuff. I had to go fast, but I can go into details one-on-one. Thanks.